Hey guys, in this video I want to go ahead and talk to you about the fundamental theorem of algebra. And all it says is that if you have a polynomial, okay, of degree n, the number of complex roots is going to be equal to the highest degree. So if you notice here you have a fourth degree polynomial, that means you're going to have four complex roots, okay? And that's all basically all it says. Now remember, complex roots incorporate two types. The real and also the imaginary, okay? If you remember a plus bi, okay? So here, all right, yeah, I give you an example. If you notice this guy's a degree of 3, 1, 2, 3, right? Because I call them terms, 1 and then 2 and then 3. So this is a degree of 3. But you see here how it crosses the x-axis on the negative side. So we would call this one negative real root. Okay, so if there's one negative real, that means there's got to be two imaginary. And that's how you would figure it out. And that helps you out in graphing the polynomial. Let's look at this guy right here. You see how many terms? 1, 2, 3, 4, 5. So this is a fifth root polynomial. Now it crosses here, so it's one negative, one real negative real root, okay? And then 4 imaginary. Okay, how do I know they're imaginary? Because the only one that crosses here is this guy. So there's one real, and it's a fifth degree, so the other have to be imaginary. Let's look at this guy right here, okay? So here it says draw a fourth degree polynomial with 2 real roots and 2 imaginary. And so you notice here, anything with a degree of 4 is going to look like a W. Okay, so here I go ahead and crossed it here, 1, 2. So this is one real positive root, and this is, one real negative root, and this is one real positive root. Okay, so right here you got a fourth degree, and then the other one, you got two real roots, and then you got 2 imaginary. Okay. What about this guy? What do you notice? It crosses here once, twice, 3, 4. So if you follow it, you go 1, 2, 3, 4. So that's a fourth degree also, okay? And it has 4 real roots, okay? 4 real roots, and that means it has 0 imaginary, okay? So there's different variations, all right? But what about if they don't give you a graph? Let's say they give you a just a function like this, right? Now, how do you do that, right? Let's say just give me the polynomial. They don't give me the graph. Well, we have something called Descartes' rule of signs from René Descartes. He was a very well-known mathematician. If you notice that, if you ever heard of the Cartesian plane, well, that comes from him. Okay, and he says in order to find the number of positive real roots, okay, in a polynomial, all you got to do is look at how it changes from positive to negative. Okay, so if you notice here, you see this is the coefficient is positive, right? And then it goes to negative, so that's one sign change. Then it goes from negative to positive. That's another sign change. So it changes twice, okay? All right, so this guy has either 2 real positive roots or it's less than by an even number of sign changes. So it's either going to have 2 real or it's going to have 0 positive, okay? So it decreases by an even number, okay? So you have 2 real positive, then if you decrease it by an even number, it gives you a 0. So it either has 2 real positive roots or no positive roots. Okay. Now the same goes with the negative real roots. Okay. Well, how do you do the negative? Well, you're gonna replace the x with a negative. Okay, and this is my original. So if I replace it with a negative, here negative x to the fourth, anything to the even power is gonna stay, positive. Any negative number to the odd is going to stay odd, okay? So that means this guy would be negative, but negative times a negative is a positive. So again, negative to the second power, that's even, so that's going to stay positive. And this guy stays the same. So if you notice, there's no sign change. So we have 2 real positive roots, and then we have no negative roots because the sign doesn't change. It's positive, 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 positive. They're all positive. Okay, now remember, when I talk about real positive, that means on this side. So here are the real positive roots, here are the real negative roots. And that kind of helps you out as you're doing your graph. So I know a lot of professors, they talk about this and it's important for them. So if they talk about it, it's like, what is that? What does that mean? Well, now you know. And it's not very difficult to do. So let's go ahead and see if we can do 2 examples here. So they're going to ask you to find the number of real roots. They'll probably say positive or negative. So let's just start off with a positive here, right? So we have this polynomial here. And we got to figure out, okay, it goes from negative to positive. So that's one sign change. You see that? And then it goes to positive, and that's it. And then it goes from positive to what? Negative. So here's one, here's another. So that means we have 2 positive real roots. Or, remember that or is going to be less than by an even number. So even goes by 2, 4, 6, 8. So less than by 2. So that means either 2 or 0. Okay. Positive, same thing, real roots. Okay. So I'm done with that guy. So now I got to do the negative. Okay, so I'm going to go ahead and do, instead of x, I'm going to do negative x. And a lot of students, they just kind of get confused with this, right? They put a negative in there. They want to see real numbers. Well, get in the habit, because your professors, they work a lot of abstract math, and they're going to expect you to know this, okay? But it's not very difficult. So now think about it. Any negative to the odd power is always going to be negative. So negative times this negative is going to be positive. So this guy's going to be positive 2x to the 5th. Okay. Negative to the odd power, that's going to stay negative. Okay. So that's going to be negative x cubed. Okay. This is already negative, right? Negative to the 1, you can think about it that way, but that's going to stay negative. So it's negative 2x and then minus 1. So now let's count the sign changes. So positive to negative, and then negative to negative, there's no sign change, and then negative to negative, no sign change. So now this guy is going to have only one real, what? Negative, right? Because we're doing the negative, okay, one real negative root, okay? And that's it, because I can't go ahead and decrease by 2, right? I can't go down by 2. So for this guy, it's either going to have 2 positive real roots or 0, and it's also going to have one real negative root, and that's it. So it's one of them is going to be here, and you're probably going to have either 2 here or none here, which is good and helpful, because then that way it tells you how to graph the function, okay, how it's going to look. So let's go ahead and do one more. Okay, let's go ahead and look at the positive. Sometimes students get confused with this one, but same process. From positive to negative, so there's only one sign change, right? So that means it's going to be one real, what? Positive root, okay? And of course, I can't go decrease by an even, so I'm done with that. So now I'm going to go ahead and do the other one. I'm going to do the f of negative x. So let's go ahead and plug in the negative x. And the reason this is helpful is just because, you know, in college, your professors, they're going to expect you just to be able to do this abstract. Negative to an odd power, that's going to be negative, okay. And then negative times negative, that's a positive. So you can have 64x. And then if you notice here, it goes from negative 3 to a positive 64. So you only have one sign change. So you're going to have one real, what? Negative, okay, negative root, okay. And that's helpful. And actually, we could say, so this guy has 2 roots, right? One real positive, one real negative. Now, how many imaginaries is it going to have? Okay, you see the degree is 7, right? So it's going to have 7 complex roots. 2 of them are real. That means 5 of them are going to be imaginary. Okay, and if you would graph this, you can go ahead and see why the multiplicity factor gets involved. Okay, guys, so that's how you do René Descartes' rule of signs, and that's how you find the number of roots or graph the number of roots that they give you. All right, guys, so hopefully that helps, and I'll see you guys next time.